Alright, welcome back. Now in this particular video, we're going to consider what is referred to as the correlation, right? We're going to consider what is referred to as correlation. So let's get to understand the intuition behind this correlation and how it's going to be relevant in our journey as data scientist or machine learning engineer. Okay, so the correlation is nothing but it actually describes the degree of relationship, right, that is between two variables. So if you have two variables, say x and then y, right, we can actually find the relationship between these two variables, okay, using what is the concept using the concept of correlation, right? So we have several examples that we're going to actually consider to get to understand this better. Now, if you take the example on your screen right now, if you, let's say you want to actually measure your calorie intake, right? Let me actually change this. Let's say you want to measure your calorie intake as against your weight, right? As against your weight. So is it that the more you take in calories, right, the more your weight goes up? Or maybe when you take less calories, then your weight comes down? Or you take more calories, then your weight comes down? Or you take less calories, your weight is going up? I mean, is there any correlation? Is there any relationship between your calorie intake and then your weight, right? So we can actually find the correlation by just measuring the correlation coefficient between caloric intake and also your weight. Okay, if you want to say measure the relationship or the association between your eye color, right, your eye color, and maybe your relative's eye color, right, you can also do that. You can also find that kind of a relationship or correlation. Or maybe your GPA, right, the time you study versus your GPA. It's just that when you study for more hours, if you study for more hours, then your GPA goes up. Or maybe you study for more hours, your GPA comes down. Or you study for more hours and then or maybe you study for less hours, then your GPA goes up. Or you study for less hours, your GPA goes up. I mean, there are several analogies that you can actually make over here and then get to measure the relationship between the time that you study and then your GPA, right? So we're going to find such relationships over and over again. I mean, it's going to be part of the projects that we're going to do, okay? And we're going to use the correlation concept over here to actually get to understand it. All right, so let's actually move on further to see the correlation coefficient and how we measure this correlation. Okay, now the correlation coefficient is actually a value which lies between 1 and then -1, right? So we have -1 and then we have all the way to 1, right? All the way to 1. To +1. Okay, so we also have 0 in the middle. That is from -1 to 1. We have 0 in the middle. So when we talk about the correlation coefficient, you can have a high correlation. That is when the value is closer to, say, 1, right? When the value is closer to 1, either 1 or -1, right? So you can have a negative correlation, right? You can have a negative correlation, or you can have a positive correlation. That is, for instance, if we take the time and your GPA, that's the time that you study, right? The time that you use to study and your GPA, right? So it can have a positive correlation or a negative correlation. Maybe the more you study, right, the more your GPA goes up, so that becomes a positive correlation. Or maybe the more you study, your GPA goes down, that becomes a negative correlation. Okay, so we can actually see that if you have a value, right, if you want to measure how strong this correlation is, then we use what is called the correlation coefficient. We use the correlation coefficient, and the coefficient is nothing but the value which is lying between -1 and then +1, okay, which is lying between -1 and +1. So the more the value gets closer to 1, the stronger the correlation, right? So in this case, maybe you measure the correlation between the time that you study and your GPA, and then maybe you come up with a correlation coefficient of, say, 0.8, right? Then we can see that you have a strong positive correlation, right? And if we come up with, say, negative correlation, -0.8, then we can say that you have a strong negative correlation, right? So the strong positive correlation over here is going to be like the more you study, the more your GPA goes up. So that is strong positive correlation. And if you have negative 0.8, then you have a strong negative correlation, which means that the more you study, the less your GPA, right? The less your GPA. So that becomes a stronger negative correlation over there. Okay, we're going to see more of this as we progress in the course, right? So the idea here is to get you introduced to all these concepts so that when we get to the lab session where we're doing more of the projects, I mean, things will become easier for you to easily grasp, right? And I mean, you're actually going to get more understanding when you put this into practice. When we're doing the projects, you're actually going to get a more intuition behind these concepts. Okay, so this is a visual representation of what we were dealing with earlier on, what we were talking about. Now, let's say that we have this. Normally, what we're going to do is that we're going to combine correlation, right? We're going to combine correlation with the regression, right? We're going to combine correlation with regression. I'm going to talk about these two, I mean, in a moment to come, right? So don't worry about that. All right, now what is happening over here is that you have if you plot your correlation, right, and you have it in this form. So in this case, you can see that normally we are going to fit a line over here. We're going to fit a line over here. When we talk about the regression, when it gets to the linear regression or maybe the logistic regression class, you're going to actually see more of this, right? Now you're going to normally fit a line here, and what you want is most of your data points to lie as close to this line as possible, right? You want most of your data points to lie as close to this line as possible. Now if you have your direction going upwards like this, right, then we say that you have a strong positive correlation, right, where all the data points lie closer to each other, right? The data points lies very, very close to each other, and the direction is quite steep, right? So we can actually say that we have a strong positive correlation. So this could be around positive 0.8, right, or maybe 0.9 or something like that. Okay, so that becomes a strong positive correlation. Okay, now this is also a positive correlation, right, in the same upwards direction. This is also a positive correlation, right? It's also a positive correlation, but this is not as strong as this. So this could be maybe around 0.6 or maybe 0.5, right? Maybe 0.5. All right, so this is also a positive correlation, but it's not as strong as this. All right, so in that case, we say that you have a moderate positive correlation, right? The relationship between the two variables are moderate. All right, it's positive, but it's moderate. All right, you also can have a situation where you will have it in this way. You're going to have it in this way, where it's actually sloping downwards, right? And then it's quite steep, right? It's quite steep. You can see that most of the data points lie closer to each other, right? They all lie closer to each other. In that case, you have a negative correlation, right? And it's very strong. So this becomes a strong negative correlation. So this could be negative 0.8 or maybe negative 0.9, right? Something like that. Okay, so this becomes a strong negative correlation. And if we take this one, it's also sloping downwards, right, in the same direction, but you can see that the data points are not lying closer to each other as compared to this one, right? So in this case, you still have a negative correlation, right, as they are steeping down, they're sloping downwards, but the correlation is quite moderate, right? So we say that you have a moderate negative correlation. All right, you can also have a situation where there's no correlation at all. You can see that it's going up or it's sloping down, right? You cannot actually identify that. So in that case, we say that you have no correlation at all, right? And also a situation where it seems that it's sloping down, but you can also see that some part of it is actually sloping upwards. So it's more like a curve form. So we call it curvilinear relationship. Okay, you have a curvilinear relationship. So mostly you're going to see either one of these, right? You're mostly going to see either one of these, right? Either strong positive correlation or moderate positive correlation, or strong negative correlation, or moderate negative correlation, or no correlation at all. This is quite rare to actually come up with, but these ones are the ones that you can actually see them most of the time. Okay, so that's basically an intuition behind this correlation and how how you can actually interpret it. We're going to see more of this when we get to the linear regression and logistic regression class. All right, so let's get an understanding of this so that when you get there, things will become easier to grasp. Okay, now that this one is done, the next concept that we're going to learn with regards to this correlation is that you have to take note that correlation does not mean causation, right? The fact that one variable is related to another does not mean that that variable is actually causing that other variable, right? For instance, if you take your weight, for instance, right? If you take your weight, for instance, the fact that you take your intake of calorie, right, is correlated, right? Is correlated with your weight. Does not mean that your caloric intake is the one causing your weight. So maybe you have a heavy weight. So maybe you have a heavy weight, right? So the fact that you take in calories does not mean that that's the one causing your weight, right? Maybe it could be a bad habit, right? Maybe lack of exercise or something like that, or maybe it could be some part it could be caused by genetics, right? So it's not necessarily that if it's something is correlated with one another, then one is causing the other. No, I mean normally it can actually be from different results. For instance, if you take your GPA, right? If you take your GPA, right, your GPA, and also if you take the GPA and then also the time that you use to study, right? The fact that these two are correlated doesn't mean that one is causing the other. Maybe you have a high GPA, right? You have a high GPA, maybe 3.5 out of say 4, right? But it doesn't mean that the more you study, the more your GPA is going to be high. Normally it happens normally, but it doesn't necessarily mean that. Maybe something else. Maybe you can still study for longer hours, but you can still have a low GPA, right? Maybe something else might happen during the examination time, or maybe what you learned will not even appear in the examination paper, and you can actually fail miserably, right? Sometimes you will not even learn for longer hours, but you can still pass very well. Okay, so there are a lot of aberrations or a lot of inconsistencies in there, okay, that you can actually relate this to. So the fact that your GPA is correlated with your time that you study does not mean that maybe the time you study is the one causing your GPA to be higher. All right, so you have to actually get to that one in the first place, right? So this is a note that you need to actually get to understand, that the fact that one variable is correlated with the other doesn't mean that one variable is causing the other. Okay, so I hope you have a better understanding of it. This is very important to actually to actually note, right? So I'll urge you to even write it down so that you will not forget this concept, right? The fact that one variable is correlated with the other does not mean that one is causing the other, because you might have a lot of situations, a lot of use cases that you measure the correlation, and if you don't take care, you're going to jump into conclusion that yes, this is causing the other. Maybe a product that people are buying, right, and some of their behavior, maybe you measure the number of times the customer visits the website, or if it is an e-commerce, right, the number of times the customer visits the website. You cannot say that if a customer visits the website frequently is the reason why the company is having a higher revenue, right? You cannot do that. Customer visiting the website frequently can have a high correlation with the revenue of the company, but it doesn't mean that if a customer visits the website frequently, it's the reason or it's the cause of the company having a high revenue. You need to get to that one in the first place. It requires more investigation, more analysis before you come to a conclusion. Okay, so now that is clear, let's actually move on to the next concept in correlation. All right, so we're going to consider the various types of correlation, and normally we have these 4 correlations that you might be seeing over and over again as we progress. Right, you might be seeing these 4 types of correlation over and over again. So what are these 4 types of correlation? Let's try to understand each of them. So we have PSN correlation, which is widely used, which you're going to see it over and over again, and even in this class you're going to see this PSN correlation over and over again. We also have a candle rank correlation. We have the spearman correlation. We have a point by serial correlation. So you either see the PSN correlation or you either see the spearman correlation, right? You're going to see either one of these in measuring correlation coefficient. Okay, so let's proceed further and then see this PSN correlation further. So as I said, PSN correlation is the most widely used correlation statistic, right, that we use to measure the relationship between variables, right? The relationship between variables. So for instance, if you want to consider, say, the stock market price, right, the stock market price, we normally measure how two stocks are related to each other. So for instance, the stock price of, say, Amazon, right, the stock price of, say, Amazon and Apple, right, Amazon and Apple. So normally we measure the relationship between these stock prices, and we actually use what is called a PSN correlation. You can use the others, I mean, maybe the candle or the point by serial, but normally or the spearman, right? Normally we use the PSN correlation for that. You can stick to one of them and it works perfectly. All right, now if you've done your basic statistics in your college, maybe in your 12th grade or something, or 10th grade, normally you actually might have come across this huge formula here, right, which is nothing but just multiplying some x values in here, right, finding the sum of x. So if you have for instance, if you have, let me actually do this, if you have x here, right, and then you have y, don't forget that correlation is just measuring the relationship between two variables, right? So if you have x here, you might be having some values for x, so maybe 10, maybe 5, maybe 15, a lot of values in here. Okay, you might have same another values for this, maybe you might have 2, 11, 14, 17, a lot of values in here too. Okay, so what happens over here for this particular formula is that you find your x, y, right? So which is nothing but just multiplication of this. So it's going to be, say, 10 multiplied by 2, which is going to give you 20 over here. So that's x, y over here. Okay, that's x, y, and then you multiply, say, 5 multiplied by 11, you get, say, 55. So you're going to do it for all the other data points, right? You're going to do it for all the other data points, and then later on you sum all of them. So that's going to give you x, y. That's going to give you the summation of that. That's what you can see over here, and then the total number of points that you have. So maybe in this case we have the total number of points to be, say, 1,000, right? To be, say, 1,000. So that 1,000 is going to be represented over here, and then you find the sum of x. So the sum of x over here is what we can have over here, and then we find the sum of y, right? Sum of y is what is going to be represented over here, and then over here it's just x squared. So this x, you need to find the square of that, squared, right? So whatever value here, for instance 10 is here, you find that the square of that is going to give you 100. 5 is here, square of that is going to give you 25. You do it for all the others. So that after that you find the sum of that, you find the sum of the s squared, which is going to give you whatever sum that you get here. So that is what is here, and this n is just the same thing. It's going to be, in this case we say it's going to be 1,000. You put it here, all right, minus you find the sum of this one, you just find the square of that, right? So that is actually going to be put here. You do the same thing for y too. So for y, you find y squared as well, right? So that's going to be y squared, and then whatever values that y is having. So 2 here is going to be 4, 11 here is going to be 1 to 1. So you do it for all of them over here, right? You're going to find this, the square of all of them, right? And then after that you find the sum of that. So that's going to be the sum of y squared, and that is actually going to be put here, and this is just 1,000, right? And then the same way, whatever sum here, you find the square of that, that is going to be put here. Okay, so this is just a simple formula, just that it's just look big, but it's just a simple thing. If you have a data set and you're calculating this, it's just a simple calculation. Okay, but however, when we get to the Jupyter notebook and we're doing this, we're not going to do any of this, right? We're not going to do any calculations. We're not going to do anything like this, right? What we're going to do is that we have a function. We already have a function in Python that takes care of this. We have an inbuilt function that we can use. So in Python, we can just use this inbuilt function call, right? So whatever, if we have a data set like this, right? So in this case, we would have maybe represent this with X and then Y, and then find, if we want to find the correlation between set power length and then set power width, we would have calculated it using that huge formula that we're having, right? A lot of stuff over there. But we're not going to do this. If we use this core, right? So we use dataset.core function over here. We're going to have our correlation, right? We're going to have our correlation coefficient just like that. So this is just the only thing that we need, right? So the formula has been inbuilt in this one for us, so we don't need to do those calculations. We're not going to do any of the calculations that we saw earlier on, right? We're not going to use this formula anyway. We're not going to use it. Okay, we have an inbuilt function that we actually going to use. Okay, now I mean this makes things simple when we're doing our exploratory data analysis, because we don't actually need to do any calculations. All these have been inbuilt for us. What you need to understand is what your end goal is and what you need to do before you get to the end goal, right? That's what you need to actually understand. But for the calculation and everything, we have functions for almost everything. So if you want to find, as we saw in the previous videos, if you want to find a standard deviation, right? If you want to find a standard deviation, you just do whatever your data set is. So you just pick your data and then you do .std, right? You just use the std function. If you want to find if you want to find the minimum, in your data set, you just do .min. You just use the min function. You don't need to do any calculation. All of these have been calculated for us, where you don't actually need to do anything, right? If you want to find the variance, you just data.val, right? You just do that. You don't need to use the variance formula to calculate anything. All right. So we're going to see a lot of this as we progress in this course. All right. Now, there are some things that might come in handy if you want to use this PSN Coloration. There are some real life examples that PSN Coloration or Coloration in general will come in handy for you to actually get to understand that. So for instance, if you want to say measure the if you want to say arrive at this question, you want to answer this question like, is there any statistically significant relationship between the age as measured in years and also the height of the person, right? So if you want to measure, say, the age of the person, right, the age of the person and the height of the person, is it that if the person, the more the person grows, the taller the person is, right? Or maybe if the person grows to a certain age, the person starts to grow shorter, the person becomes shorter? Or is there any relationship? If you want to find something like that, then you need to resort to what is called a PSN correlation to find this correlation, right? For instance, the temperature, right? The temperature and also the sale of an ice cream, right? The sale of an ice cream. So is it that if it is cold, right? Is it that it's cold, people buy less of an ice cream? People buy less of an ice cream. Or if it is hot, then people buy more of an ice cream, right? Can we have such correlation? Is there any relationship like that? So we can actually measure this just using the PSN correlation, right? For instance, the job satisfaction and also the salary that people take. Can we actually or maybe the income, can we actually have a relationship like that? So PSN correlation will help us answer such real life situations. We're going to see some of them as we progress in this course. Okay, now as I said, we're going to actually combine this correlation with the regression to get a better understanding and also be able to solve these real life scenarios. We're going to combine this correlation and then regression. So let's compare the two and then see. Most of the time people confuse with correlation and then regression. So let's get to understanding right from here before we get to a hands-on, before we get to the lab sessions. Let's get to understand this. So so far we have seen correlation, right? We have seen correlation, and we say that correlation measures the relationship, right, between two variables, right? It measures the relationship between variables. Now, if we take the regression, right, regression comes in after you have found the relationship. So if you take, say, the GPA, right, the GPA of students and also the time that they study, right? Now, if you find the relationship between these two variables, right? Find the relationship between these two variables. Then later on, you might want to predict a new student's GPA based on the time that they study. So maybe you find this relationship and you got something like 0.8, right? That's the correlation coefficient that you got. So this becomes a strong positive correlation or relationship here. So it means that the more the person studies, the higher the person's GPA. So maybe this could be the time, right? And this could be the person's GPA, right? So the more the person study, right, the more the person study, the higher their GPA. Okay, so maybe you have something like this. All right, so if you study for low hours, so maybe for say maybe 2 hours, right, your GPA normally will be low, right? Maybe something like, if it is out of 4, maybe your GPA could be say 2, right? And if we study for say maybe for 5 hours, right, for 5 hours, maybe your GPA could be high as maybe 30.8, right? So if a new student comes in and the person studies for say 4.5 hours, right, we can predict that this person's GPA will be high, maybe around 3.5, right? This person's GPA can be high. Or maybe the person studied for say 2.5 hours, we can see that this person's GPA will be less, maybe something like 2.5. okay, this person's GPA. So in order for you to make this kind of a prediction, that's when regression comes in. This when regression analysis actually comes in. Right, this one regression actually comes in. So after you find a relationship to be either positive or negative, either strong or moderate, right, or maybe there's no correlation, right, that can, or maybe curvilinear, which is quite rare to actually come up with. And then after you find that relationship, then you use the regression to make further predictions based on the relationship. Okay, so based on the relationship that you have, we can make future predictions, right, using the regression. So that's the relationship between this these two, that's correlation and regression. All right, so as we progress, we're going to see more of these two in hand as they work hand in hand, as they go together. All right, so in the next video, what we're going to see is probability. We're now going to consider what probability is, what conditional probability is, and all the concepts and the probability that you really need to understand before we proceed to the machine learning class. All right, so see you in the next video.